One quick thing to note before we even begin to graph the polynomials is to understand what polynomials will look like when they get graphed, right? So one thing that we know about all polynomials functions is that the graphs are smooth, they're connected, and continuous, right? So what does that mean? It means that there's no gaps or corners. So there's no rough corner, the way like an absolute value function has that real sharp V, right? That would be kind of considered a corner. There's no gaps, meaning there's no jump in the function, right? So it's always kind of smooth, right? One way to think about it is it's some sort of S shape most of the time, right? Or a U shape, or a combination of both. But if you can draw it out without lifting your pencil, for the most part, it's probably a polynomial. All right. And then the domain of all polynomials, what's great about them is that they are from negative infinity to infinity, right? So that means that they continue to the left and to the right forever. All right. Something else to know is that even degree polynomials, for example, a power of 2, even degree, right? What do you know about a polynomial that has an even degree? It's a quadratic, right? Makes a parabola. So a parabola, there's only 2 ways to draw a parabola. It's either opening up on both sides, or it's opening down on both sides, right? Every even degree polynomial, whether it's power 4, power 6, power 8, will have either ending with both arrows moving up or ending with both arrows moving down, regardless of what happens in the middle. Odd degree polynomials, they're kind of like John Travolta's, like the 70s, you know what I'm talking about? One going up, one going down, or the other way. John Travolta's probably way too old for you guys. The idea is that they usually behave in a way where one of them is headed downwards while the other one is headed upwards, right? Or flipped around. Maybe this way. Okay. Those are terrible sketches, all right? But that's the idea, is that even degree polynomials, they have the same end behavior. They either both move up or they both move down. If it's an odd degree polynomial, then they will have one ending that's growing, one ending that's falling, or the other way around. Okay, so they never both go in the same direction. They will usually end this way or this way. Okay, and the more you learn about different types of polynomials like cubic functions, powers of 4, again, you'll see a lot of this in pre-calc. That'll become familiar. All right. Okay, so we finally get to the part where we're going to sketch. We need information about this graph before we can even move on to the sketching part. The first thing we need to find is what we found last time. We need to find the zeros and then identify the multiplicity at those zeros. So first step here is whatever function you're given, we set it equal to 0, and we're going to solve to find those roots, aka intercepts, aka zeros. Okay, so since I have 2 factors here, remember I can split this. This is x squared equal to 0, and the other one would be x plus 3 equal to 0. Okay, now I can solve for x over here on the left. I could do kind of like the shortcut way, which would be to square root both sides, and I would end up with x is equal to the square root of 0, which is 0. All right, now this solution, x equals 0, what multiplicity does it have? We talked about this one last time. It's a multiplicity of 2. That's right. Remember I said that x squared is also the same thing as x times x equal to 0. So you could technically say x equals 0, x equals 0. So that solution is actually there twice. So this is a multiplicity of 2. Okay. All right. And then the next one, we'll solve for x here, subtract 3 from both sides. So I have x equals negative 3. X equals negative 3, what kind of multiplicity does this 0 have? Yeah, it's only a multiplicity of 1 because the solution only shows up once. Versus on the other side, we could argue that, hey, that x squared, x times x, that gives us the same solution twice. So that's why 0 has a multiplicity of 2. Okay, so that's critical information, right? We're going to use that to then be able to at least start the sketching of our curve. All right, and that's where we're going to go onto the other side. So let me drop in a xy axis. Okay. Now, another name that you might end up hearing in future years is 0 and -3. These are what we would also call critical points, right? A critical point, because that's typically where a decision has to be made, right? So we have 0 and -3. These are our critical points. All right. So if I were to label them on this x-axis, right, I would put a point here at 0 when x is 0. Right, so we know that this coordinate would be 0, 0. And another coordinate when x is -3. So we go to the left 3 spaces. This would be -3, comma 0. Okay. All right. Now, these points also, what we're going to do is we need to figure out where is the graph to the left of -3, where is the graph in between -3 and 0, and where is the graph after 0? Meaning, is the curve going to be down here or is it going to be up here? Right. We don't know. Is the curve going to be down here in this space or is it going to be right here in this space? Or is it going to be up here in this space or down here? Right. We don't know. Right. There's options for both. So what we need to do is called something called sign analysis. All right. With sign analysis, what we're doing is we're basically creating a number line right underneath, and we're going to line it up with our critical points. -3 here, 0 here. Okay. And what we're trying to figure out is the graph above the x-axis or below the x-axis on the left side of -3? Is it going to be above the axis or below the x-axis in between -3 and 0? And then is the graph going to be above the x-axis after 0, or is it going to be below? All right. So how do we test all this out? We're going to go back and we're going to use this original function, right? X squared times x plus 3. And so sign analysis means we're just going to use signs. Like we're just going to use numbers here to determine whether is this going to be positive or is this going to be negative, and that's going to tell us whether the graph will be below or above the x-axis. All right. So check this out. I want to know to the left of -3, I want to pick some number, right? Let's call that -4. We're going to test. We're going to use a test point here, -4. All right. And we want to see, okay, if I were to take -4 and plug it into the function x squared times x plus 3, is that going to end up being a positive number or a negative number? Okay. So let's think about what would happen. My test point is going to get plugged into this. All right. So that's -4 squared times -4 plus 3. Okay. I don't care what the number will be. I just care is the number going to be a positive or is the number going to be a negative? Well, -4 squared, well, negative squared becomes a positive. -4 plus 3, that's a negative number. So what I end up with here is a product of a positive times a negative. So what does that tell me? That the solution, the value is going to end up being negative. So that tells me that to the left of -3, my graph is going to end up being down here underneath the x-axis, right? So part of my sketch would be, okay, after -3, my curve is decreasing. It's below the x-axis, right? So that's what my sign analysis tells me. The -4 is a test point. I could have picked -5 or -6, whichever. All right, but since we're just doing rough sketches, I don't need to know exact outputs. I just need to know, is that output's going to be a positive or a negative? If it would have been a positive, I would have sketched up here. Okay, but since I got a negative in my sine analysis, I know that negative means below, so below the x-axis. Okay. Now, why did I not go past -3? Well, I need to double check. -3 has a multiplicity of 1. All right, so what do we remember about last time? If I have a multiplicity of 1, that's an odd multiplicity, will the curve, will the actual curve, will it cross through the x-axis or will it bounce back? It's going to cross. Good. All right, so it's going to cross. All right, so that should line up with whatever we get in the sine analysis between -3 and 0, right? If it crosses, that means that we should get a positive value when we do sine analysis between -3 and 0. So let's say I were to pick a number here. Let's say -2. We're going to test -2. So we test it into that same function, x squared times x plus 3. So we take -2 squared, -2 plus 3. Once again, I'm just testing for what is the sign going to be. So a negative squared, well, that becomes a positive. -2 plus 3, that's also a positive. So I get positive times positive, that's a positive. So I know that my curve will be above the x-axis in between this entire interval. Okay, so I know it's going to cross at -3. It's going to go up. But then at some point, I'm going to have to hit that 0, 0 point, right? That's one of my zeros. It's one of my x-intercepts. So at some point, this is going to have to curve back down. Right? We don't really know how high it goes, right? But that's something that then we can kind of plug in the holes a little bit later. Right? For now, we need to understand that if it crosses at -3 because it had a multiplicity of 1, and it also needs to touch this point at 0, 0, then that means that at some point it had to curve. It had to curve and it had to come back down because it's headed over to touch this point again. All right. And then we need to make a decision. When I get to 0, is my curve going to cross or is it going to bounce back? What's the multiplicity at x equal to 0? My multiplicity is 2, correct? And the multiplicity of 2 means even multiplicity. So even multiplicity, will it cross the x-axis or will it just touch and then bounce back? It should bounce back, right? That's what we know about even multiplicities. So let's see. Let's confirm it with our sine analysis. So we're going to pick a value that's on the right side of 1. I'm sorry, on the right side of 0. So let's pick 1. We're going to run the sine analysis, make sure that it is going to match up with what the multiplicity says the graph should be doing. So in this case, right, we take 1, square it, 1 plus 3. 1 squared is a positive. 1 plus 3 is also another positive. So positive times positive is positive. So that means that our curve should be above the x-axis on this side of 0. So that matches what the multiplicity is telling us, is that once it hits 0, this curve should bounce off of that point and then be headed upwards. Okay. And this is your very, very rough sketch of what this polynomial will essentially look like. So it is an odd degree polynomial. That's correct, right? You can tell, can't you? Because what if you would have distributed this x squared to both of these terms? What do you get? That's x to the third plus 3x squared. So we always look for the largest polynomial, the largest power. The largest power is 3. That's how we know it's odd, right? And you knew it was odd because look at the end behavior. On one side, the graph is decreasing, and on the other side of the graph, it's increasing. These are opposites, right? Got a little John Travolta going on. So that's how we know. All right, any questions there? All right, so this is the foundation, kind of the building blocks of how to sketch out a graph. In next year's class, you'll find you'll do a little bit more. You'll do a little bit more of a precise graph. Now, obviously, if we really wanted to know, like, how high does this curve go, right? This is probably the part that's the least precise. We don't really know where the curve actually turns around, right? But one of the ways that I learned, one of the tricks is, let's say you have a gap here from -3. Obviously, this would be -2. This would be -1. Typically, if you wanted to use a point in between, a lot of us think that the curve is going to happen, like the vertex or this maximum would happen in between -3 and 0, right? So somewhere along here, right? We always think things happen in the middle. That's not always the case. One of the better points to use is the point that's on the left, right? So in this case, -2, right? So a little bit to the left of the middle. What point is that -2? If we really wanted to know how high this curve went, we could then plug it into the function just to get an idea, right? So we take -2, we square it, -2 plus 3. -2 squared would be 4. This would be 1. So it looks like at 4, right, it actually reaches a height of 4. So 1, 2, 3, 4. So if I really did want to adjust my curve, I could, right, make it a little more precise, and I could have it grow where it's going to touch that point. And then it has to curve back down in order for it to touch the other intercept. How do we know it doesn't go down again? Because there are no other x-intercepts. There is no other x-intercept over here that the curve has to go touch. Okay, so that's how we know. The only time that the polynomial or that the curve will touch the x-axis is at the critical points, at -3 and at 0. If there is no other x-intercept or critical point, there's no reason for the curve to come back down. It will usually maintain its end behavior after it has touched or passed through its last intercept. Right? Not only that, we did sine analysis, which tells us that everything to the left of -3, the curve will be below the x-axis. Everything between -3 and 0, the curve will be above the x-axis, right? So everything right here, notice that all of our green is above x-axis. And then after 0, it's all positives. So this curve needs to be above the x-axis. If x equals 0 was a multiplicity of 3, would we still have to do sine analysis for it? Well, sine analysis helps confirm what you should know about the multiplicity. So let's say, for example, multiplicity of 3 at x equals 0. Then we should know then that it should cross, right? That it should cross through the x-axis, and then it would probably switch back from positive to negative. So the sine analysis is just to give us more information to make sure that we draw the curve in the correct places. But yes, sine analysis is something that you need to do because that's how you show basically like your proof that you know that the curve should be in the right place above or below the x-axis. Any other questions? All right, let's try out next example. All right, so what do we know? We want to sketch out the graph. We need to find the zeros and then the multiplicities for each one of those zeros. So convert f of x into 0. We have x to the third plus 2x squared minus 3x. What approach should I take from here if I'm looking for zeros? What should be my first step? Yeah, there's a GCF, right? You see that? You can factor out an x from each term. That leaves us with x times x squared plus 2x minus 3 equal to 0. Okay. And then what would I need to do now? Before I do that, I have a trinomial here. I know that I have to find 3 different solutions. So before I even set the x equal to 0, I have a trinomial. What should I do with the trinomial? Yeah, you want to factor that first. Okay, so this one should be fairly simple. Product of the numbers has to multiply to be -3, but add up to be +2. So this is likely going to be x plus 3, x minus 1 times x is equal to 0. All right, and you can double check my work just in case, but I think those are the correct factors. All right, so now this means we get to now split this up. X equals 0, x plus 3 equals 0, x minus 1 equals 0. What do we know about the multiplicities of each one of these solutions? Right, we can solve. This one will be -3. This one will be +1. They all have a multiplicity of 1, that's right. So multiplicity of 1, which means odd multiplicity, which means what else for us? How does that help us when we're drawing the curves? What do we know at each one of those intercepts? What's going to happen? They're going to cross, exactly, right? So maybe we won't need to do sign analysis because now we know that, hey, it's supposed to cross at every interval, right? So maybe we can do this in a simpler way without having to test every interval. If we know what happens in the first interval and it crosses, then it should just switch. Negative, positive, or positive, negative, right? That's a tool right there. That's a quick little trick where it saves us some time. So let's go ahead and draw out the XY axis first. Not there. Go over here. All right. And then we have critical points at 0, -3, and then also +1. Okay, so real quick, sign analysis down at the bottom. Okay, and let's test out the interval to the left of -3. So we just need to pick a number. Let's say it's -4. And we want to use like this factored version right here because this is pretty easy to determine like what the signs will be if we just plug in -4. So let me bring that over. All right, let's say we take -4, we were to plug it in. Well, that would be -4 plus 3, -4 minus 1. Well, -4 is negative. -4 plus 3 is also negative. And -4 minus 1 is also negative, right? So I only care about the signs, right? What are the signs? So in this case, it's negative times negative, which is positive, times negative again. So that tells us that, hey, on this side of -3, the curve will be below, right? It'll be below, right? So it's going to be decreasing. We don't really know at what rate, but we know it's decreasing. All right. Then if that's the case, and -3 has a multiplicity of 1, then after it passes -3, will it cross? Will it bounce back? -3 has a multiplicity of 1. What does that mean for us? What happens to the curve? It'll touch -3 and then it crosses. Correct. So then we know, hey, the curve should be then above. So then this means it switches back to positives up here. Okay. All right. We eventually have to get back down and touch 0, right? So for now, we're just going to kind of do a rough sketch. We know it needs to come back down. It has to touch 0. At 0, we also had multiplicity of 1. So what do we know? What's going to happen in between, or what's going to happen after it touches 0? It crosses again. So now the curve should be underneath. Okay. And then it has to go back and touch the other x-intercept. So we need to curve it. And then after it touches 1, what do we know? Does it cross or does it bounce back? What multiplicity did we have for x equals 1? It crosses again, right? Right, so this is our real rough sketch of this polynomial, right? Super rough. But I guess this kind of answers your question earlier about Haley, about like, do we have to do sign analysis on every interval? If you are comfortable with what the multiplicity is telling you to do, then as long as you know the first one, you start the sign analysis on the left, on the furthest to the left, you start there, right? That sign analysis told you, okay, that it should be below the x-axis. But if your multiplicity is 1 at every single interval or at every x-intercept, then you know it's going to cross, then cross back, and then cross back again. So you know it's just going to keep alternating, plus or minus, plus, minus, plus. Okay. So we did a real quick sketch. I want to figure out a little bit more of the details here. So typically, what do we test for? Well, if it's -3 and 0, that's -2 here and -1 here. So let's test this point that's closest to the left. All right, so we're going to test it out using the factored format. All right, let's plug it in. That'll be -2, -2 plus 3, -2 minus 1. All right, we want to find the actual output so that we have a more precise y value about how tall the curve goes. So that's still -2. That'll be 1, and that'll be -3. So -2 times 1 times -3 looks like that output is going to be 6. So I'm going to have to adjust this, and I'm going to adjust the scale. I'm going to make these go by 2s. So I actually have a point up here. So I'm going to try to sketch it through. Through that point. So I have something a little more precise. All right, so this is a real rough sketch. Any questions there for number 2? Any questions? Are we okay? All right. Let me give you a chance here to try this last one on your own. I'll give you about 5-6 minutes, and then we will come back and review it. All right, so go ahead, try it out. Okay, so last one here, sketch the graph, right? We know what to do, need to find the zeros. So we have 0 is equal to negative x to the third plus x squared plus 12x. All right, what do we know we need to do in order to break this down? What's our next step? GCF, that's right, okay. There you go, negative x, I like that. Why is that? Because we have a negative as a leading coefficient. So we're gonna go ahead and divide everything by negative x. That gives us negative x times x squared plus x plus, I'm sorry, I gotta switch my signs, sorry. That'd be minus x and minus 12. And that's equal to 0. Okay, so negative x, I want to factor then the rest of the trinomial. What are those factors going to be? Not negative x minus 3. Because I already factored out that negative. So for me, at least, because the negative is already factored, I should have a factor of x plus 3 and x minus 4. Okay, so now I have my three different factors. I want to go ahead and use zero product property, solve for x. So my first one would be negative x equal to 0. Next one is x plus 3 equal to 0. Last one is x minus 4 is equal to 0. All right, so if we want to solve for x here, that's real simple. Divide by negative 1. X, 0 divided by negative 1 is still 0. Here, let's subtract 3. X is equal to negative 3. And then the last one, we add 4. So x equals 4. Okay, so now we know, hey, we have 0, negative 3, and 4. What are the multiplicities for each one of them? Yeah, it's just multiplicity of 1, right? It only shows up once as a solution, so they all have multiplicity of 1, which means odd multiplicity. Okay, so odd multiplicity at each intercept, that means it's going to cross at each intercept, right? So let's see what kind of graph we can sketch out here. Oops, wrong place. All right. So let's go ahead and draw in those critical points. One is at 0. One is at negative 3. And the other one is at positive 4. All right, so 0, 0, 4, 0, negative 3, 0. All right, so real quick, we'll do a sign analysis on just one side to at least know where we need to start, right? Do we need to start above or below the x-axis? And then if we know that it's a multiplicity of 1, it's going to cross every time. So it's just going to flip-flop, right? So let's try this out. Draw a quick little number line. Add negative 3, then add 0, then add 4. All right, we're going to test a number. Let's go ahead and pick negative 4 to test. All right, we want to see if that's going to land above or below the x-axis so that we can start our sketching. So I'm going to go ahead and use the factored version. Right, it's pretty easy to plug in numbers and get results. So if the function is negative x times x plus 3 times x minus 4, right? When I substitute in my test point, right? Negative 4 is my test point. So I would still have a negative out front. That's part of the formula. Then I plug in negative 4. Then negative 4 plus 3. And then negative 4 minus 4. Okay, so a lot of negatives, a lot of moving parts. Let's just keep track of whether it's a positive number or a negative number, right? Negative on the outside, negative 4. Negative 4 plus 3, that's another negative. Negative 4 minus 4, that's another negative. So what you end up with is negative times negative times negative times negative. That actually ends up being a positive, okay? That ends up being a positive. There's a positive number here. So that means that our graph will begin where? Above or below the x-axis on the left side of negative 3. How'd I get 4 negatives? Well, this is my factored function right here. I used a test point negative 4. I went in and I plugged it in everywhere that I had x. So I plugged it in here, here, and here. There was already a negative on the outside. If you didn't factor out the negative from the GCF at the beginning, then that might be where the problem is. Yeah, so that we should give you 4 negatives. You're multiplying 4 negatives together. That gives you a positive. All right. So for us, that means that we're going to have function is going to be above the x-axis, right? It's above the x-axis. So then we should have something kind of like that. Ish. Okay. All right. Now, what do we know at negative 3? It's a multiplicity of 1. So what do we know about the curve? It's going to bounce, head back up, or is it going to cross and then move into the negative? That's right, right? It's going to cross, so we're going to end up down here somewhere. All right. We know the curve has to turn back because it has to touch the other x-intercept. Okay, we don't really know how far down it goes, but a little bit later, we could maybe try to find an exact point. For now, we know it curves back. It's got to touch the other intercept. Okay, what do we know about the multiplicity at 0? Is this going to lead us to cross one more time, or is it going to bounce? It's going to cross again, right? So if we started with positive, then it went underneath. Now it's going to cross, so it's going to go back to positive above the x-axis. And then let's say it were to touch 4, right? Let's say we're to touch 4. Once again, is that going to cross or bounce back based on the multiplicity that we have? It's going to cross, right? So it's going to go from the positive territory down to the negative territory. Okay, that's what helps us avoid having to do a sign analysis in each one of these intervals, right? Knowing what the multiplicity is doing helps us avoid all this extra work because we know it's either going to cross or it's going to bounce back. So comes up, right? And then it's going to take a dip, right? So we have another John Travolta, but this time it's going kind of like in the other direction. Okay, so the only thing left is probably just to identify some more detailed points, right? Try to find out like how far down did it go in this region, right? In this region of the graph, right? How far down does it actually go? And then actually found out how high would this go, right? We don't really know. We just kind of sketched it out real rough. So what we'll do is we'll take a test point. We know that this would be -2, this would be -1. Once again, whenever there's two intercepts, you want to find the number closer to the left. So in this case, we're going to test -2. We're going to plug that in. We're going to try to find an output. Okay, so the function that we're testing into is -x, x plus 3, x minus 4. So I'm going to plug in -2 because I want to know what that output would be. So negative times -2, -2 plus 3, -2 minus 4. All right, so negative times negative, that's positive. -2 plus 3, that's 1. -2 minus 4 is -6. All right, so that actually ends up being -12. All right, so this actually goes down pretty far. All right, let's see. Maybe I can go by fours. -4, -8, -12. Okay. So if I adjust my x-axis, then I could say at -2, there's a point right here. So my curve, maybe it's a little bit steeper, actually. Maybe it does more like this. Hits that point for sure. Let me try. All right, so pretty steep. 2 is not a general term. What do you mean by 2 being a general term? You mean -2? -2 is a number that I picked because in between the interval -3 and 0, I wanted to know how far down does that curve go. So in between that interval, the number closer to the left, right, is -2. So I want to pick the number closer to the left to get an output. All right, we're gonna do the same thing over here as well, just to get an idea. All right, this is in the situation where there's kind of like no middle number to test. Okay, over here we're gonna try to test to see how high this function goes. All right, we have a couple options, right? We could test 1, 2, 3. All right, let's test 2. Let's just see how far that goes, right? That's kind of like right in the center of 0 and 4. So let's try it out. Same function, -x, x plus 3, x minus 4. So negative times 2, 2 plus 3, 2 minus 4. So -2 times 5 times -2, that's actually going to be positive 20. So I guess it's good I went by fours because that'd be 4, 8, 12, 16, and 20. So at positive 2, that height is way up here. So I want to make sure I hit that point too. All right, and there it is.